Hello, everyone. So, in the day one of our project session, we picked a topic that is energy price prediction, and there we explored, understood the data, its features, what it comprises of. It's related to your renewable and non renewable energy sources, how much production or energy generation they do, and accordingly we do have the prices for the energy or electricity. Okay, there were many features present in the data, as you have seen, both from renewable and non renewable. You are having coal products, you are having hydroelectricity features which are used for the generation, then you have onshore, offshore. Okay, so such kind of features are available. They do have the null values. Okay, so after studying all these features, we started our project implementation. And in the project implementation, what we have explored so far is, okay, like how many duplicates are there in the data, how many null values are present in the data. Okay, and yes, some information about the data, description about the data. Okay, so we were doing some basic things as a part of EDA, that is exploratory data analysis, to understand what our data comprises of. And now we have to proceed ahead for the next part of the code. Okay, so I am sharing my entire screen now. Okay, you can now see the implementation part. Okay, here it is. So I started like adding a title, giving a image for the project, adding the necessary libraries, getting the data, printing the head and the tail of the data. Okay, then shape columns, the meaning of the columns, meaning of the features I have already included in this project implementation. Okay, and then the duplicates I have checked. I don't have any duplicates present in the data. Okay, and though we can see there are null values present in the data, if I use this term df.isnull.sum, I do find there are null values present in each and every column of the data. So here the task, the main task of data scientist comes: how to deal with such kind of data where every feature, mostly, you are having the null values. Okay, so the data which is available to us is a rough data, raw data it is. Okay, and it's not only the null values. We do have other problems also present in the data set that we will explore. Okay, so null values, then information. I printed the information. So here, all the features are having numerical values. Only the one, time, the time is having your what, object type. Rest all the features are having numerical value. Float 64, some are int 64. These are numerical values. Accordingly, I have printed the description of the data, df.describe. That's what I did. Okay, I gave the description. Description means, okay, you are focusing upon the statistical description of the data. for the numerical values. What is the minimum value? What is the maximum value? Standard deviation, and 25%, 50%, 75 distribution of the data. Okay. From here, I found the percentage of null values which are present in the data. Though you have already printed the number of null values in the data, df dot is null dot sum. Here I am taking what is the mean null values present in each and every feature, multiply it by 100. So I will be finding the percentage. Okay. So here you can see that my features are having the null values 5%, something like that. All these are nearly to the 5%. However, a feature like hydro pump storage, 100% null value. Okay, this one also offshore, 100% null value. I don't have anything to do with that. No excuses. If they are having any value, whether it's zero or in any value, but it should have something. Right now I don't have anything null. I can't fill with zero also. What can I do? 100% empty means I'm not getting any information from here. Okay, you have to decide, being as a data scientist, that if someone is having 100% null values, what is possible at this particular moment of time, what you do? Okay, their only means is I can drop them. So I dropped these two features from my data. Okay, so if any of the feature like having null values more than 50%, okay, or more than 60%, now here you will be in a dilemma what to do. If I do have some like 1%, 2% null values, or 5% also, 10% value also, I am very good, I am very much flexible in doing the imputation, filling. But 50%, 60% null values, and if you are going to fill with the dummy values, okay, either by taking the mean or the median or whatever, are you risking the things? Okay, that's the decision the data scientist needs to take. Okay, so here I took that 100% null means drop it. Then I printed the number of unique values which are present in the data. Unique, that means unique entries in each and every column. So it told me that okay, these are the unique entries. I was still shocked by seeing some of the feature that they do have only one unique value. That means the entire column is filled with only one type of value. Like generation fossil coal derived gas, only one value. Okay, one type of value. That's what I'm saying. This also, generation fossil oil shale, generation fossil peat, generation geothermal. They are having only one type of value. And if we explore ahead, there are a few more columns which are having just one unique value, and they are also like, if I checked now further, they are all zeros. They are all zeros. But now in this particular case, these which are having something, I'm not going to drop them. That's what I think. At least they are having something. They are having a value. It's not null. I'm having a information about it that okay, zero. Let's consider them. Okay, fine. So this is the unique values, and then what I did is I printed the type of the features present in the data. Okay, object type or numerical type. So I got to know that only the time is of object type. That's also I have already seen above while printing the information. I know that okay, time is object and rest all are numerical. Okay, and then what I decided that, can I split the data, because there is a proper structure of data types. That means you can have data in numerical and non-numerical. Okay, numerical further divided into discrete, continuous. Non-numerical means like, okay, like not text or something like that, which is object type. So non-numerical can be divided into categorical and non-categorical. So obviously now in this particular project, I need to draw the insights over the data. So I should know about the category or the type of the data. That will better help me to understand what is the behavior. Because analysis of discrete, analysis of continuous, analysis of categorical, analysis of non-categorical is different. They do require different plots. Okay, for discrete I have to make different plot like count plot, pie plot. For continuous I make histogram, dist plot, box plot, Boolean plot, Boxen plot. These plots I make. For categorical, yes, I can make again count plot, pie plot. For non-categorical, I need to check what can be done here. Okay, so here I try to explore my data, classify features. I prepared a method, classify features. Okay, and in this, if any of the data type of the feature is object, and if it is having less than the unique values, less than 10, then it's categorical, else it is not categorical. And if any of the data is integer or float, and if it is having less than 30 values, unique values, then it is discrete, else it is continuous. See, these numbers I decided according to the project requirement. Okay, I decided these values according to the project requirement. It's not like, sir, these are standards. No, according to the project requirement, I decided these values. You can change from your side. If you are having a different project, just kindly change according to your, okay, your wish. That's what you can do. Okay, fine. So yes, I made this method, and when I gave my data frame into this method, it classified what is categorical, what is non-categorical, what is discrete, what is continuous, and I printed. And what I got to know is time as usual, it is non-categorical object type. I got some discrete features present in my data, and these discrete features are those features which are having only one value. Okay, discrete because I put a condition, na, less than 30. Unique. So they are having only one unique value, so all they came into the discrete. Rest all are the continuous features. More than 30 unique values. They all are continuous. And when I printed the discrete values for I in discrete, print I, print the feature, print the unique values in them. So I found that generation fossil coal derived, it is having 0 and null. This feature is also having 0 and null. This feature is also having 0 and null. That means all these discrete features are having 0 and a null value. Nothing else. So the unique value they do only have is 0. Rest, if there is no entry, they are null. Okay. So fine. I printed the value counts for them. That how many zeros are there, kindly tell. Okay, so like 35,046. Every feature is having this much number of zeros, 35,000, 35,046. Every feature is having, every discrete feature is having 35,000 zeros. And there are some null values also. So what I decided is that you are a discrete, you are having 35,000 zeros, and I need to fill the null values because because I can't keep them empty. I use a code for a feature in discrete. Okay, take every discrete feature, take every feature because we are right now analyzing discrete features only. So take every feature, every discrete feature, and find the mode of it. Find the mode value. Remember, if you want to impute, impute means fill. If you want to fill null value, null values present in categorical data or discrete data, remember the only logic says is mode, and mode is the most frequent. value present in the data. So we are having only zeros, which is frequently used in the data. Obviously, I need to impute with the zero only. कोई ऑप्शन ही नहीं है ना मेरे पास, सब जीरो से फिल हो जाएंगे. Okay, so fill NA, fill null values with the mode. Now discrete don't have any null value. All features are 0 0. So the point is, sir, if they are having zero, that means there is no production there. Can't we drop these features? They are not having any production. They are not contributing to the energy. Neither they are contributing to the price. But I keep one thing in mind that okay, maybe in future if we have some data where values are not zero, and we are dropping this feature because still zero was present. It was not like entire null as we have seen in the previous two features. So this is not, and it's zero, not null. Okay, so only few values are null, so we filled with zero. So let's keep it. Don't drop, keep it, रख के रखो ऐसे, drop मत करना. Zero है तो we will move with zero only. Let it be. Okay. So now if I check the unique values of the discrete, all are zeros. Previously it was zero and null. Now all are zero. Okay, fine. So this is how I solved the problem of discrete. That is why I made a diagram here. You divide your data into this types. It is very much important. And kindly solve the problem of each one. Okay, do that. Fine. So discrete I solved. Now I got an option now to solve the problem of continuous. See, continuous are also having the null values. But there is a twist in continuous. What is the twist? See, what values I do called as continuous, which are not countable, which comes under some range. They are not they are not countable. Range. Okay. So we are not going to fill them with mode. No, it's not possible. Either we fill with mean, either we fill with median. These are the two possibilities to fill the null values of a continuous feature, either by mean, either by median. The most preferred is mean. This is preferred, but still, unless and until we don't do some analysis, we are not going to fill directly with the mean. This is preferred, but no, we have to do some analysis. What kind of analysis it is? Okay, the analysis is related to skewness. Okay, the analysis is related to the skewness, orientation of the plot. Okay, orientation of the plot feature. And what plot? Histogram. We'll make histogram, or I can say dist plot, distribution plot, and see what is the skewness in the data. We do have positive skewness, we do have negative skewness. Two kinds of skewness we are having. So, positive skewness, we do have a long tail on the right. In negative skewness, we do have a long tail on the left. That's what we are having. So, you know what I did? I made histoplot, histogram for each and every continuous feature at the moment. This is how it looks. Histogram of each and every feature, each and every continuous feature. See here. Okay, long tail on the right. Here also skewed. Every data is skewed here. Okay, there is a skewness in the data. All the content again long tail here. Again long tail on the left. So every data is skewed here. Fine. So by making continuous plot, then I made dist plot also, distribution plot. See, histogram and dist plot, they do have same figures. If you see, dist plot also looks like same, but it don't have the bins. Yeah, bin nahi hote. Okay, it don't have like clear bins. In histogram, we do have the clear bins like this. Okay, we do have like this, but in dist plot we don't have like bins. Okay, it make like this. It do define a region. Define a region. That's what it do. That means it shows area bounded. That's what dist plot do. Area bounded. And what it consider is dist plot. It consider entire area is equal to one. Entire area equal to one. And okay, whatever be the fraction of values which are coming here. Okay, like na here, this fraction of values. So how much area they do capture, it is represented with the help of density. Okay, so you can see the dist plot distribution. Here on y-axis, you can see the density. The entire area is equal to 1, and this represents the density. Okay, so this much amount of data, it is having density like between 0 and 0.001. It is having this, it is having the density of this much thing, and it's having a density like this is highest. It's between 0.007 to 0.008. However, in case of histogram, we are having counting on y-axis. Both looks like similar. Histogram and dist plot both look similar. In histogram, I am having towers, bins. Here, I am not specifically making the bins. Just entire region is shaded. Its area is equal to one. The bounding is equal to one, and we do consider these data, that how much density they acquire in that fraction of one, how much fraction they acquire in the entire one, and that's what we put here in form of density. This is dist plot. So histoplot, dist plot. Then I also made like, okay, fine, nothing, only these two plots I made. I need to check the orientation of the data, because continuous features are having null values and I need to fill them. खाली नहीं रखने का, भरना है उसको. I need to fill them. But with whom? By mean or by median? That I have to decide. Don't jump that, okay, fill with mean, because it was general tendency. No, we don't do that. We check the orientation. No. Find the skewness also. Df continuous dot skew. Find the skewness of the data. So you can see this is positively skewed, this is negatively skewed, positively skewed, negatively skewed, positive, 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 negative. So some are positively skewed, some are negatively skewed. Okay, fine. Now, how to interpret it? If the skewness is greater than 0, this is positive skewness, and in positive skewness, we are having a long tail on the right. Remember, these are the main concept of statistics. That's what we do teach, and that's what we do study in statistics. Skewness 0, long tail on the right. And when we are having a long tail on the right, mean is greater than the median. And if mean is greater than the median, then in such cases, we have to impute, or fill null values with mean. Remember, make a star. If mean is greater than the median, then we have to fill the null values with mean. So this happens when you are having positive, okay, skewness, when we are having a long tail on the right. Okay, so fill it with the mean. And if we are having negative skewness, long tail on the left, in that particular case, median is greater than the mean. So we have to fill with the median, not with the mean. These are standards. Okay, fill that with a median. And if the skewness is nothing, then obviously it's a normal. If there is no skewness in the data, the point is clear that your plot is a normal distribution. It is normally distributed. So this is standard plot. Yes, anyone want to say something?
Yes, sir. Sorry for interruption.
Hmm,
I'm Devashish.
hmm,
So the doubt here is that
hmm,
means you said when mean is more than the median,
hmm,
then as per one of the standard rule, then we'll go with the mean.
hmm. Yeah.
But sir, if you look at that graph, that means it is showing a right skewed data. So it might be there might be some of the outliers present at the
हाँ
actual
सर, ये
part of
ये
the
इसी के कारण है सर. Yes, I definitely agree with you. These tails are because not some. There are many outliers present in the data. These
okay.
outliers are
So,
responsible, no sir. Yeah, because of
mhm.
these long tails, no outliers are responsible. Definitely.
Uh, so my doubt is
Huh.
that means we have not gone with the outlier treatment yet,
Huh.
but we are going to fill the missing value with mean for this
Huh.
particular scenario.
Huh. Huh.
And mean also is being affected by the outlier value.
Huh.
Then
Sir,
how
actually,
will
I want to tell you, I want to put one remark here. See, mean, see, imputation with mean and the median. The point is, median is less affected by outlier. This is less affected by outlier. And mean is more affected by outlier. Affected by outlier. Okay, that's the point that how these two values, mean and the median. And you are absolutely correct that we are having a long tail in the data. Obviously, outliers are present. That's the reason that we got a long tail in the data. Okay, and when we are having a long tail on the right hand side, then the value of mean got shifted here. You can see on the scale because we are having so many values present here on the right hand side. So mean got shift here, and the value of mean, median, mode. Okay, you can check from this x-axis. Mean is more than the median, and if the mean is more than the median, the standard says that you have to impute with the mean. However, in case of this kind of orientation, okay, here the values are being on the left hand side are being more. Mean is present here. Mean will shift here. Median will be more than the mean. In this particular case, I prefer that fill with the median, not with the mean. Whoever is the greatest, according to the rules, whoever is the greatest, stats says that fill with that. So in this particular case, I will fill with the median, not with the mean. Okay, and yes, outliers are putting impact in the distribution. And the point here is, if I remove outlier that I have considered in this particular code, outlier removal also, but I don't want to lose the data. That is also concern. If you remove the outlier, you are in a loss of something. You know about that. I need to take care of the data too. Okay, so that the outlier concept we will study ahead. Her These are the certain norms which you have to just take care. Keep this in mind with whom we have to impute, and that's what I did in the code. You can see here. Okay, so yeah, if I need to impute the continuous features, if the skewness is greater than 0, okay, fine. I guess here the concept change. Certainly there is a change in the concept. Okay, what I told, just correct it. If it is skew value is greater than 0, then it filled with the median. Okay, then it filled with the median. Maybe like when I was explaining in a flow, it happened. Okay, yeah, again. Yes, Manish. Yes, Mr. Manish. Say.
Yeah. So can we say if mean is like impacted by outliers?
Hmm.
So first we have to handle outliers
Hmm.
and then after imputation.
See, first we have to handle outlier. Well,
because of if
uh,
there are a lot of outliers, so yeah,
present in the data. There are a lot of outliers
imputation
present
value,
in
yeah.
the data, and removal of the outlier, you are still existing with the null values. I don't prefer that you will remove the outlier first. I don't prefer this thing. Let remove the outlier first.
Yes, sir. Because renewable resources,
Hmm.
the solars are in peak time is energy is very high,
Huh.
so it will be not considered that is outlier.
Hmm. Will not consider that. In
Mm.
context to our project, also we will not consider this thing, as sir also told. Okay, that removal of outlier, that will be loss of lot of values present in the data.
Yes, sir. The because it's generation related data, no,
In
sir.
generation there will be an issue, so our entire analysis will go wrong. We can't do that. Okay.
Okay, so it is kind of like an anomaly in
Hmm.
data, we can
Hmm.
say.
We can consider
Yeah.
the it will be anomaly. And one more thing, as I told above, related to the skewness. Okay, I told that when it is positively skewed, when mean is greater than the median, because I have read this concept. When mean is greater than the median, whoever has been the greatest, fill with that. Fill with that. However, I got one more approach here in this particular case. And the one statement which I told about, that is putting a contradiction to the view, to the opinion. And the contradiction was like this. I just told that if mean is greater than the median, that means you are having such kind of plot. You are having such kind of plot. And we are having a long tail here. And that's the reason that mean is present on this particular side and median is present here. So obviously outliers are impacting your data distribution. That's the reason that mean is present here in this particular case. Okay, at this particular value. And if I fill with the median here, if I fill with the median here in the positive skewness, does it, that means the null values, does it shift the orientation or what it will do towards the center more? The mean is getting the weightage, median is getting the weightage for the positively skewed. Does a shift towards the median, isn't it too hurry that shifting towards the median is a good way? Because what I know about is, if the mean is greater than the median, we replace with mean. And if median is greater than the mean, we replace with median. If median is greater than the mean, what is your opinion here? Yes, what do you want to say? Any opinion here? The replacement was done if the skewness is greater than 0, that means positively skewed. And what's a positive skewness? It says that, okay, this point I already raised. Median is less affected by the outlier. Mean is more affected by the outliers. And mean is closer to the bulk values. Okay, that's what I already told. Fine. And positively skewed, that means the mean will be greater than the median, which will be greater than the mode. So this feature has a right tail. And the mean is less than the median in negatively skewed. Okay. And which is less than the mode. Okay, so mean is less than the mode in negatively skewed. Okay, so in negatively skewed, first mean come. Okay, like this. First mean will come, then mode will come, then median will come. Okay, is it the way? That's what you are understanding. Mean is less than the median. Okay, fine. So it will be like this: mean, then it will be median, then it will be mode, like this. So median is greater than the mean here. And whether it is left skewed or right skewed, left also obviously outlier. That's the reason it got stretched, isn't it? Either on right also outlier, either on left also. The stretching is because of outliers present in the data, for wrong or faulty entries that was considered according to the statistics. The only concern is right now what I told initially, on initial basis, that if mean is greater than median, impute with mean. And if median is greater than mean, impute with median. Do you agree with the opinion, or do you go with the code? In code, for positive skewness, I took median. Negative, I took mean. What do you think? Okay, with what you will go? And else, okay, with the mean only, because mean is the preferred. Else mean. Yes. Any suggestion over this imputation?
We'll go with the thing what you said as
Yeah.
per the statistical standard.
Yes.
Whatever you describe as per the statistical norm, that
Huh.
means if mean is greater than the median, will go with the mean because it will be varying by the outlier value, which is
Huh.
not the outlier, but it is the general pattern of the data.
General pattern
So
of the.
no, no,
Huh.
that means as per the current data
Huh.
energy, that
Huh.
means it might be the high production might have happened, so which
Hmm.
might be little to the outlier.
Hmm.
But in real, it is not an
Sir,
outlier. But
sir,
as per the
outlier has always been a doubtful thing. In reality, it
so
may not be an outlier, but according to the statistics, it was considered outlier. That's what I already said.
yes, so whatever you said and whatever the code is implemented, I think both are reversal.
Both are reversal.
Yes, that means that there you said no. If it is positive skew, that
Huh.
means mean will be higher than median.
Huh. Mean is
So
more than
in
the
that case,
median.
we'll
Hmm.
we'll impute with the mean value. But
Huh.
here it is positive.
Huh.
We
Huh.
are checking what we are imputing with the median.
Here it is put with the median. So that's what I'm
Yes.
asking about the opinion. Shall we go with this, or it requires to change? Shall we go with this, or it requires a change? That's what I'm
Can we
asking.
ignore the imputation in this scenario, sir? Because the very less entries, 16, 19 less.
Sir, only
We
5%.
have
In
lot.
continuous, we are having 5% imputation. But sir, we
So
are not.
directly we neglect them and you go.
Okay.
Means you do
Okay.
not
Either.
input.
Okay. 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 If we are not inputting, now,
Otherwise, it is contaminate.
sir. Okay, it will contaminate. Sir, for that, we have to drop the rows. And sir, dropping the rows
Yeah,
again
yeah,
will
yeah.
be issue,
Yeah,
sir.
sir. Because we have a lot of entries, no?
That will be an issue, sir. But sir, for continuous, but for other features, that is
Hmm.
also one of the things sir is saying. Here we are having date column also, sir, and date is on regular basis, date and
It is,
hourly basis.
we announcing time series or
Sir, time series
i-
will use later on. Right now, we'll just use a regression.
so we skipping is not affected on us. In a time series required
It is required.
continuous.
Okay, all right. So, okay, one suggestion
So you
came.
can
Hmm.
directly we can ignore it.
Ignore it. Okay, fine, fine. So ignorance is one of the point which has been raised. Apart from that, still I have this question, that whether the imputation is fine or not. This one or the one which I told, they are opposite to each other. But I want your final opinion so I can proceed.
Sir,
Yes,
second one is fine, sir.
this one is fine.
This code one is fine, sir.
Okay, code one is fine. Okay, that means if skewness is more, then you have to impute with the median.
Impute with the median, sir.
Why? What could be the reason? What could be
Sir,
the?
if we
Hmm.
input with the mean,
Hmm.
I think
Hmm. Hmm.
so. I think tail will get more longer uh,
Okay,
because
tail will. Hmm.
tail will get more longer, and if we
Hmm.
put with median,
Hmm.
so so it
So why
becomes
shouldn't this
normal.
thing comes under the case of left also? In
Sir,
left
same
also,
come.
say the
Sir,
tail also
left.
is more on the left now. If the tail is more on the left, that is negative skewed. Why this thing doesn't comes under the
Sir,
left?
tail is more on the left.
Huh.
Median is more.
Huh. Median is
So,
more.
uh, but mean is less.
Mean
So,
is less. Okay.
uh, okay.
So that means you are reversing the concept. Whichever is less, impute. Matlab, like this. See, there should be a technical answer for that.
Yes.
There should be proper answer for that. For imputation.
Yeah, we can.
Hmm. Yes, yes. Please.
Yeah, we can do one more thing.
Hmm.
If it is like a highly skewed,
Hmm.
we can put some sort of threshold.
Huh.
Okay.
Okay. Yeah.
So if it is like a crossing the threshold,
Hmm.
so we can implement your logic.
Hmm.
Else, we can ignore it.
Okay. Else we can
That
ignore it.
could be, and yeah, yeah.
Okay. All right. So here in this particular case, at the uh, this moment, whatever suggestion schemes, I request everyone to keep noted, and we are right now proceeding with this imputation. That means I am having the median for skewness greater than zero and less than zero. I'm putting with the mean. Rest, if there is a case, okay, you are going to replace with the mean because this is the most preferred one. And now I don't have any null values in any of the feature. All the null values are filled in continuous features. I don't have anyone. So discrete also filled and continuous also filled. There was 5% of gap in the continuous. Most of the features are having 5% null values. Now they are filled. And then here I am making a plot that is your mean, median, and mode all being shown on the histogram in this particular code. All mean, median, mode are shown on the histogram by line. A XP line. This is the code. Okay, we can show that. Here it is. You can see. Here mean is greater than median 367 and then mode 361. Okay, now by seeing before and after plots, okay, check it out. This is your distribution of generation biomass. Okay, if you see the histoplot here, okay, see the histoplot here for biomass. What change we got after imputing with the median for positive skewness? I guess this is positively skewed biomass. So we imputed with the median here for positively. You can see the above plot and this one plot. Do you feel any change or what? Is there any change? Now the mean is 383, median is 367, mode is 361 because now all the values are filled. And if we calculate the mean, because you are filled with the median, so median is what kind of value? What kind of value? That means the number of terms. If it is positive, then take the sum of the terms. Like if there are six values, so you'll take the sum of third and the fourth. Okay, and if there are odd values, so the median will be, for example, there are five values, so median will be three, third term, and you're filled with the median here. That only one term. That's all been filled with the same term, median. Only 5% of data was like to be empty. Does it put any impact? I don't think that there is a lot of impact here related to it. I've drawn all these mean, median, mode for each and every plot. You can see the lines red, green, and the blue. Okay, you can see in these plots. Negatively skewed, okay, mean. Positively skewed, median. Okay, so the one which is less, you are imputing that. And the term which I have studied is the one which is more, you have to impute that. Okay, anyways, this is what I got. And one suggestion, drop the 5% of the data. Okay, but still, if I don't want to lose anything, I impute it. That's it. Here is a box plot. Now you can see the outliers present in the data. Okay, you can see in biomass generation, I don't have anything. In generation fossil gas, I do have so many outliers. Here I don't have anything. Here I do have. So there are features which are having the outliers present. With the box plot, it shows the outliers. Okay, and I did made a code for outlier also. See, I calculated first quartile, I calculated third quartile, and I found interquartile range, lower bound, upper bound. Also, you very well know this formula. Okay, 1.5 IQR Q1 minus. So this is the lower bound, this is upper bound, and whatever be the values which are less than the lower bound, whatever the values which are more than the upper bound, I just filtered them out. These are the outliers. Okay, and I printed that how many outliers are there. So obviously there are different numbers of outliers present in the data. Okay, like 87 are in generation biomass, generation fossil 2187. So if I'm going to remove the outliers, that will be a big challenge for me. 3772. Okay, these are 87. Okay, I don't, it will not impact much, but this is thousands of outliers in some features. So it will totally eliminate 3772 rows approximately, I am saying. Okay, so I will be having a lack of data. Yes, Mr. Manish, you can say.
Yeah, Nirmal, could you please like repeat which one is the preferred for mean, median, and mode?
Which,
Like the final outcome? Yeah.
what is the final outcome? See, there are two things I want to put here. What I have read is a value which is more. That is what we are going to impute. If mean is greater than the median, we have to impute with the mean. And if median is greater than the mean, we have to impute with the median. That's what I have read. Okay. However, the logic which I have used in the code, that is a opposite one. Okay. In context of the skewness. Fine. What we have used, if skewed is greater than 0, that means positively skewed, long tail on the right, where
Mhm.
mean is greater than the median. Okay. And a thought, a thought that mean is affected more by the outliers, and mean is more, and it is affected more by the outliers. So let's try with the median. Okay, let's try with the median by keeping that thought into consideration. Okay, because mean is more, it is affected by outliers, and if you fill the null values with the mean, obviously it will be total impact on the data. So they imputed with the median. That is a general explanation of the code. Okay, I hope you understood what I said.
Okay, yeah.
Okay, so
Thank you.
in that, if you think in that context, this code is absolutely correct, because a value which is impacted more by the outlier, and if you're filling the null values with that value only, obviously wrong. Na? Am I right? Am I right, sir? Am I right, na, sir? Isn't it? And a value again in, but now what's the consideration on the, what's the consideration on the left skewed? What's the consideration here? If we are having a left skewed, again I'm picking here, median is more than the mean. Again, because of outliers, this more are outliers, so mean is shifted here. Mean is shifted here. But since it is again impact to mean ko hoga, but its value will be less than the median. Its value will be less than the median. So though it is having an impact, still we are using mean when we are having left skewed or less than 0, that is negatively skewed. You are filling with the mean because of less value. Okay, so that's I told. These are the core concepts of stats. Interpretation can be like different. How you think over the point, how you think over what should be the correct one. There could be. That's why I told. Now I do have two terminologies. One I said, okay, if mean is greater than the median, fill with that mean. If median is greater than the mean, fill with the median. I told that is the first concept, first terminology. Second is if you concern, okay, that on right tail there's a right tail, and mean is the greatest, and mean is impacted by huge tail on the right, and if you fill null values with this mean value, that's not correct. So this is another interpretation. Okay, so you have to be quite judgmental here. What can be done? Okay, fine. Well, it's a good discussion. Let's proceed. Okay, now, so yeah, outliers. I I showed here that so many outliers are present, thousands. The highest number is 3772. I am not interested in dropping, but let's see if you drop. For example, if I need to clean my data frame, I already got that these are the outliers. Okay, let me remove the outliers. I remove them. So initially, my data was of 35,000, and removing the outlier bring it to 25,000. Okay, this is not at all of proportions. I can't take a risk of 30,000, 35,000, and come down to 25,000. That's not at all. I think, sir, you told, okay, what could be the possibility. So this is the practical scenario which is happening. After 10,000 entries are lost. So if the outliers are there, let it be. Most of the times I keep the outliers. Only when there is very less chance that my data will be least reduced, then only I remove outliers. Else, okay. So this is the experiment I did. Still, I will be working on my initial data frame only. On this data only I will work. I will not remove the outlier. But I shown this thing. Okay. Uh, Here I made scatter plot between continuous versus continuous. Now, if you talk about the visualization, so what we have done, if you plan, certainly, because a lot of discussion held in this session, for continuous only, this is the kind of data which is creating trouble. This is the data because I don't have any problem with discrete. It's easy. Mode, replacement. It's easy to draw the plot for them. So everything is easy related to the discrete, related to the categorical. But things are complicated related to the continuous. If it is empty, again, you have to think a lot. That's what we did right now. किससे करना है, मीन से करना है, मीडियन से करना है, फिर अभी बहुत टेंशन हो गया. If the values are empty, challenging task. Okay, outlier, again challenging. Whether you have to drop, whether not to drop. Then see the relationship between the features. In visualization, you have to draw like scatter plot or line plot. Check how the features are correlated. By scatter plot, if I get this kind of relationship between x and y, obviously this is linearly dependent, these two features. So again, I need to take a decision that either of them I need to drop because this is a linear relationship. Correlation, that's what I say. Correlation. Okay, and this happened here. This will happen if you see the scatter plot. See, actual, and I made only with right now with price actual. That is my target. However, you can make the scatter plot between each to each, so that will go so long. So I haven't took that idea. I just took, let's take my target and let's take rest of the features and make a scatter plot. Okay, and this is good thing now because I want to have the features to have a good relationship with the target. That's what I want. Huh? Because the logic says that tar- uh, target and features should have good correlation. However, feature should not have good correlation because we assume independence. Our algorithms ask for that. The feature should have to be independent of each other. However, they should have a good correlation with the target. ये चलेगा, ये नहीं चलेगा. Because if they are correlated with each other, so our model will not learn. It will memorize. वो रटेगा, सीखेगा नहीं. क्यों? If these are correlated with each other, our model, who is looking forward to understand the patterns in the data, who is looking forward to find the insights in the data, so rather than going forward for the complexity, that means वो search करे point को, if I do have the correspondence correlation between the feature, so if a point is present for a feature here, another point of a different feature will be present near to it. So model will not struggle to find this particular point. It will connect easily. And at the end, At the end, model says that yes, I'm good. I found each and every point. That see, I learned everything. This is what model will say, and this is ultimate result of overfitting then. Because in reality, the data will be not like that. Okay, in reality, the data will not like that.
Hi, sir. I
Yeah.
have one doubt here.
Yeah. Please say.
So here almost more 20 columns were taken
Hmm.
into account.
Hmm.
So will there be a chance of multicollinearity here?
Multicollinearity.
Hmm.
Okay. Yes, multicollinearity will be there. Multiple features will be related to each other. Yeah, there is a chance. And that's what we are looking forward ahead by doing the correlation, by finding the correlation. Okay. But in this particular plot, I told that I'm specific with the price, that is my target, and rest of the feature. Okay, this plot is related to scatter plot for between actual price and only the feature. Then next I proceeded to find the correlation between the continuous features. I printed the correlation matrix also, that how these features are correlated positively, negatively, how they are correlated with each other. You very well know what's a positive negative correlation. Okay, that means if this is the relationship, it's positively correlated, this is negatively correlated, and this is no correlation. Okay, when we are having such kind of line, no correlation. Okay, there is a multicollinearity. Multiple features are correlated. Yes, there is a chance. For that, I wrote a code related to it. Okay, first let me show you the heat map related to it. See, it's very easy to find the correlation. Just use the method CORR. You very well know about it. So df and just take the continuous features and write CORR correlation. So I will be having like all the features here also, all the features here also, and it will give some numerical value. It's like a ratio, okay, of value to value. Okay, value to value. It is ratio correlation. Okay, so I made heat map for the correlation, and here you can see that check 0.43, 0.46. That means 43%, 46% correlation between the features. Like if I consider this generation fossil oil, it is 46% correlated with generation biomass. Okay, and we can say we can find some highest correlation also. Check 99%. That means forecast solar day ahead is 99% correlated with generation solar. So definitely I'm going to drop one of the feature, any one of them. The one who is in a good correlation with the target, I will keep it, and another I will drop. There is no sense of keeping the correlation again, though there is a loss in the data, but not that much because these are correlated now. So the points are mapping each other. Points are mapping each other. Correlation, that means like that thing. So 90, this one is also 99%, like 99%. This is also 99%. This is also 99%. I'm getting some features which are 99% correlated. So here I put a threshold. Before that, what I did, this is my target feature price. I find the correlation of features with the target. Let me first do one thing. How features are correlated with the target. Let me find this thing first. Okay, and I got idea that price day ahead is 73% correlated with the target. Okay, good. That's what I want. So all these features are showing their correlation with the target. The least correlated is, okay, like this, inversely correlated, generation hydro pump storage consumption. And that's what it means, generation hydro pump storage consumption. That is when we are already available with the stored electricity, stored energy. So we will supply it. During the winter season, if the electricity requirement is less, we will store. And when there is a requirement, we will supply. Okay, so this one is negatively correlated, minus 42, inverse. Okay, and these are least correlated, like only 16%, 14%, 10%. See, negative correlation, this is negative correlation. Negative means if price is increasing, this is decreasing, but minus is just a direction. Minus is just a direction. It's absolutely clear that if price is increasing, generation, hydro pump, storage consumption is 42% decreasing. Price is increasing, this is 42% decreasing. That's what it means. Okay, so still it is having a good correlation with the target, but in opposite direction. Minimum is this one, generation solar, only 9%. This one is also generation hydro reservoir, only 7% correlation with the target. This is also least, like 5%, negative direction, inverse. Okay, so what I did is I find with the target, and then what I considered correlation matrix. And here I used a logic. I put a threshold 80%. Though I thought that threshold should be like 75% is a good idea, but okay, 80%, fine. And what I did is I need to find highly correlated features. That's one question which is asked to me. That, sir, there could be multi-collinearity, multi-correlation between the features. So what I did, I need to identify the set of features which are highly correlated among each other. So I applied a loop in the correlation matrix, and I find the absolute value first, because there are negative also, no? Then there could be negative correlation also. So let's find the absolute value, positive value only, and compare it with the threshold. So any feature which is having a correlation higher than the threshold, compare each to each. Compare each feature with every other feature. And if there is a correlation higher than the threshold, 80%, okay, just do one thing, add them. Okay, just add them in your set. Just add those features in your set. Okay, and later on you can drop them. Here I have used to drop those features which are highly correlated. I applied again a loop for feature in highly correlated, because I found that who are the highly correlated features. I prepared a set of them, and then I'm applying this code to drop them. And yes, I found that there are features, these generation solar, total actual load, forecast already seen, na, 90%, 99%, it's visible. But the logic here is, very important. There is a correlation, fine, between the features, but only drop that feature which is in less correlation with the target. See, the concept says like this. That's what I applied. Let us suppose your target is T, and A and B are the two features which are correlated. In case if A is highly correlated with T, B is less correlated with T, A and B are correlated, I will take a decision, I will drop B. Why? Because A is highly correlated with T. And when I use my model, this will put an impact on the target. So it's better to keep this one rather than this one. That's the logic I have used there in the code. Okay, fine. So I got these features which are like present, but they are highly correlated. And they're not also with the target, good with the target. So drop them. Okay, now this is my cleaned data. I drop those features also. So imputation done. Those features which are unnecessary dropped. I got it. One more thing. Then one thing came into my mind. What I'm going to do with the date? What I'm going to do with the date? One suggestion came in the opening, that sir, you are not solving a problem of time series at the moment, so you can drop date. That is one of the suggestion. Okay, I agree with that. I agree. I can drop date. But then I thought, still date is having data of year, month, day, hour. Why shouldn't I do some feature engineering? And why shouldn't I make separate columns for them? Include in my data, na? Because so someone will ask you what could be the energy price in this year, in this month, and this is hour. What I'm going to answer them? I'm not doing time series, but still, let's consider it. This is my opinion. I could have dropped. Okay, that's not an issue. I could have dropped. If I'm not considering anything related to that, let's drop it. And also the suggestion which came that above, that for the null values in the continuous, you can drop them also. But I found that there are 25,000 only left. 10,000 का लॉस हो जाता वहां पे. तो आउटलायर को रिमूव नहीं करा, फिल करा. ओके, मीन से मीडियन से, दैट्स व्हाट आई डिड. और यहाँ मैं डेट को भी यूटिलाइज करना चाह रहा हूँ. इफ आई एम अवेलेबल विद समथिंग, लेट्स यूटिलाइज इट जितना हो सके. सो व्हाट आई डिड. अच्छा, इसमें एक कंसर्न हुआ मुझे. You very well know that there is a method called as to convert date into date time. There is a method which converts date into date time. I use that. But क्योंकि पैटर्न ऐसा था डेट का, वो एरर फेंक रहा था. It was giving error. There is a method which converts date into date time. You are having an object type date, you can convert it into date time. Well, it was throwing an error. Then it came into my mind, भाई ऐसा तो नहीं चलेगा. I require year, I require month, I require day, I require hour. These four things I require from the date. I need to make features, columns by these. So what I did, I used concept of regular expression. See, check here. I use concept of regular expression. I extracted year, I extracted month, I extracted day, and I extracted hour from the date pattern. I extracted all, converted into integer type. And then I drop actual time. And now I am having four different features. See, year, month, day, and hour. I decided to utilize this part of data also. Okay, so I created four new the feature engineering, creating new features. I did that. So now this is my data.
Sir,
Yeah.
taking advantage of month
Hmm.
column, can we also make summer season, winter season?
We can do that.
So we can
It can
also
also
save.
further classified, but right now I don't want to go in that particular depth. Okay. So just like year, month, this thing I did. So according to the Indian context, if I say summer season, from month one to month four, summer season, you can just write summer. From this month to this month, you are having rainy season. From this month to this month, you are having winter season. So you can make it. Instead of month, you can use seasons here, and just put a range. Okay, if this one to this summer, so this entire will be converted into another category. एक कैटेगरी और बन जाएगी, इसको ड्रॉप कर देना, फिर कर सकते हो, कोई इशू नहीं. ओके, अभी रेलेवेंट है, दिस इज रेलेवेंट. Okay, now only left with me is I created the copy of this data, and then I'm just going to use the models. I did it. ये तो आपको आगे बताऊंगा. लेकिन अभी जो आज डिस्कशन हुआ, जस्ट टेक 2 more minutes फॉर यू, आई नॉट फर्दर एक्सटेंड द थिंग्स. जो भी इंपॉर्टेंट डिस्कशन हुआ आज, वेरी इंपॉर्टेंट discussion, that is related to the imputation. Okay, and the entire story revolves around continuous features. The entire story. So the people who said that yesterday also, I got the suggestion, sir, kindly take a real data like industry data. Okay, yeah, fine. This data is also challenging. That's what you feel. We got a lot of things to know about this particular kind of data, and continuous is the challenging one rather than any of the feature. Okay, so with whom to impute? What is the final conclusion? There are two ways. If mean is greater than the median, I said replace with the mean. This is my first interpretation. Or either median is greater than the mean, replace with median. So this is my first interpretation. Second interpretation was that if mean is greater than the median, replace with median. That is for positive skewness. And if median is greater than mean, then replace with mean. This is negative skewness. The justification says that here, because mean is having higher value, and it can be more if the tail is more. If the tail going to extend, it can be more. Okay, you can have such kind of diagram also. If the tail is more, for example, this tail is going to be more, so mean will be shifted more, and median will be somehow out here. So if you are having null values, so it's saying that this person is impacted a lot with the outlier, fill with median. That's the justification and second consideration. Okay, that's the justification, second consideration, considering outlier concept, because impacting a lot on the mean. So we require good value, not impacted value. So fill with the median. That's what is said. While in case of the left skewed, median is greater than the mean is less. So we are doing the imputation. We are doing the imputation. This is the preferred one for the imputation. Take mean to do it. That's it. That's it. Only the models part we are going to do, and that will covered in the last